Hello guys, welcome to Prime Tracks. In today's tutorial, we'll be looking at calculating beam loads on a simply supported slab panel using the manual calculation approach. So we'll be calculating the beam loads for beams on grade lines 1, 2, A and B. And the design parameters are, so the dead load and live load of the slab panel are 6.8 kilonewton per square meter and 1.5 kilonewton per square meter respectively. Additionally, the beam sizes on all grade lines, that's beam on grade line 1, 2, A and B are all 200 by 450 mm. To be able to calculate the loads on the slab panel, we would first of all need to establish the load distribution on the beams. So the first thing we are going to do is to establish the load distribution on all the four beams bounded by the panel. Right, so the first thing we are going to do is one, so establish tributary areas on beam. Right, so in order to determine the tributary area on the beams, we would have to check our K, and our K is given as the ratio of our Ly to Lx. And in this case, our Ly, which is the long span, is given as 5,800 mm. Lx is 4,800 mm. So if we work that out, we'll have a ratio of 1.208. And if this value is less than 2, then this implies that we'll have a trapezoidal load distribution on the long spans and a triangular load distribution on the short spans. So we'll have this load distribution. All right. So this implies we'll have a trapezoidal load distribution on beam on grade line 1, and it will be the same load distribution on beam on grade line 2. And then on beam on grade line A and B, we'll have a triangular load distribution. So in this case, the slab is a two-way. So slab is two-way. Right. So after establishing the ratio of our Ly to Lx, the next thing we are going to do is to calculate. We are now starting the calculation on the beam loads. So calculate dead load on beam 1. So beam on grid line, let's denote it as beam 1, and beam on grid line 2 will be beam 2. That of A and B will be beam A and B respectively. So now when we consider beam on grid line 1, the total load acting on it comprises its self weight and then the tributary load from the slab that is acting on it. So we'll consider first of all, so self weight of beam 1, and that is given as the cross-sectional area multiplied by the density of concrete. So when we look at our exam tutorial, the beam sizes on all the four beams are 200 by 450. So the cross-sectional area will convert it to meters. So 0.2 multiplied by 0.45 multiplied by the density of concrete, which is 24. And if we work that out, we'll have 2.16 kilonewton per meter. So that's the first part. We've been able to calculate the self weight of beam 1. And then B, will calculate the tributary load from the slab. So tributary load from slab. And with that, we'll use the formula. So the formula is given as 1 over 2 multiplied by NDL multiplied by LX all into bracket 1 minus 1 over 3 K squared, right? Where our NDL is the dead load of slab. Our LX, we know already, that is the short span. And then our K, we've calculated that one previously. That is also a ratio of our Ly over Lx. And that gave us a value of 1.208. Right, so slotting these values in the equation, we'll have 1 over 2 times our dead load. So from the parameters, our dead load is 6.8 kilonewton per square meter. So 5 by 6.8 times the short span, and that is 4.8 meters. So 4.8 all into bracket 1 minus 1 over 3 times the k squared, which is 1.2. So 1.2 squared. Solving that, we'll have 10.74 kilonewton per meter. Right, so that is the load from the slab, right? The dead load from the slab. So our total dead load on on beam 1 will be the summation of our self weight and then the tributary load from the slab. So the self weight, we had a value of 2.16 plus 10.74, and that will give us 12.9 kilonewton per meter. So that is the dead load on the beam. Now we'll move ahead and calculate. So we are going to calculate. So calculate. So this will be 3. Calculate life load on beam 1. So with that, we are also going to, we'll just consider the tributary load from the slab. So tributary load from slab. And that will give us, we are using the same formula we used previously. We'll change the dead load to life load. So we'll have 1 over 2 multiplied by NLL multiplied by the short span Lx all into bracket 1 minus 1 on 3k squared. So if we slot in the values, we'll have 1 over 2 multiplied by NLL. So from our parameters, the life load is 1.5 kilonewton per square meter. So multiplied by 1.5, our short span is 4.8 into bracket 1 minus 1 over 3k squared. So our k, we know the value already. So that is 1.2 squared. 1.2 squared. And if we solve that, we use our calculator, we'll have 2.77 kilonewton per meter. Right. So total life load on beam 1 is 2.77 kilonewton per meter. Now from the question, we are supposed to calculate the ultimate loads on the beams, right? So in order to do that, we'd have to multiply the total dead load and life load by their respective partial factors of safety. Right. So our ultimate load will be, so 1.4, that's the partial factor of safety for dead load, multiplied by the dead load plus 1.6, which is the partial factor of safety for life load, multiplied by the life load. So these values, the 1.4 and 1.6 varies, and I'm using the British code. So with that, we'll use the 1.4 and 1.6. But if you are using the Euro code, mostly it's 1.35 for the dead load and 1.5. So it depends on the code that you are using, right? So if we slot in the values of our dead load and life load, we'll have the ultimate load being 1.4 multiplied by the dead load, and we calculated that to be, so 12.9 kilonewton per square meter. So 12.9 plus 1.6 multiplied by the life load, which is 2.77. And if we work that out, we'll have 22.5 kilonewton per meter. So this is the total, the ultimate load acting on beam 1. And it will be the same load for beam 2, because they have the same tributary load distribution, and then moreover the spans are also equal. So if I just do a quick sketch, we would have, so we'll have a uniformly distributed load. Okay, so we'll have a uniformly distributed load with magnitude 22.5 kilonewton per meter, and this will be our grid line A, and this will be grid line B, and this is the span here. So that is 5 point. Let me go back to the our sketch. So that is 5.8. So 5,000 or 5.8 meters. Right. So we'll now move on to calculate the ultimate loads on beam A and B. So that will be our step 4. So calculate ultimate loads on beam A and B. Right. So we are going to start off with the dead load. So dead load. Okay, so when we look at our sketch, our example, when we consider beams on grid lines A and B, they have triangular load distribution, right? So as we did previously, our dead load will constitute the self weight of beam 1 and the tributary load acting on from the slab acting on the beam. So first of all, we'll calculate, so self weight of beam A, and that will be, so the cross sectional area, which is 0.2 multiplied by 0.45 multiplied by 24, and that will be the same as previously because the beam sizes are the same, so 2.16 kilonewton per meter. And then the second part of the dead load will be B, so tributary load from slab.